Hello everyone, my name is Bank and I'm a certified investment banker and you are watching the Quant desk. So today I will break down the Black-Scholes model and we will first understand the idea behind the Black-Scholes model and then we will see how it is work on a practically using the Excel sheet, right? So today we will let's talk about something that quietly run the modern finance world. This is very important. A formula that is getting a Nobel Prize, right? That is the Black-Scholes model. But relax, this is not the math class. We will talk like a normal pupil, right? So the real problem is, imagine today a stock is trading at a $4,000, and you believe that in a 3 months, right, it might go up, right? So you take a bet on that on a future price. But the big question is, what should that bet be worth on a today, right? So that bet is called an option. An option is like a movie ticket. You have the right to watch the movie, but you are not forced to go, right? In the same way, an options gives you the right, but not obligation to buy or sell a stock at a fixed price in a future date. Sounds is a simple, right? But the pricing is the hard part. So why is pricing is a difficult? So the value of an option depends on a future. Let's to be honest, nobody knows the future, right? I'm not a god, and you are not a god also, right? Stock price moves are randomly, right? Someday they are calm, someday they are go crazy. So how do you put a fair price on something based on uncertainties? So that is the main problem of the traders struggling with the decades, right? So how stocks actually moves. So the Black and Scholes model started with on our basic ideas, right? Like stocks does not moves in a straight line, right? They are moving on a ups, randomly downs on a every day. So the measure this the randomness they are using on a key concept that is called volatility, right? So volatility in a simple words, volatility is just means how much our stocks are moves, right? High volatility indicates big ups and down in a stock market or stocks like a roller coaster. Low volatility it indicates the smooth movements like a slow train. For example, if a $4,000 stock has increased 25% annually, volatility, right, or a decrease, right, it does not means the stock jumps on a 25% on a daily, right? It means the daily movement is as small, but over the time, those small movements adds up. So the volatility simply puts a number and how uncertainty stock is, right? So the brilliant idea is now comes the real genuine part, the realization as something very clever, right? So the randomness of that any moves of the stock price also moves the option price, right? Listen carefully. The randomness that moves the stock price also moves the option price. So they ask, what if we buy some stocks and sell some option in just the right ratio? If we done on a perfectly, the random movements are cancel each other, right? And for that movement, the portfolio has a no risk, and that is the risk-free portfolio we have. So why this chance and why this changes are everything. So in a finance has a one golden rule, right? So if a something has a no risk, that must be earn a risk-free interest rate. So in this idea, changes the option price forever, right? Because once you can create a risk-free position, you don't care about the opinion anymore, right? So it does not matter if our investors are the optimistic or scary. Only five things are matter: stock price today, strike price, time left, risk free rate, volatility, and nothing less, right? So, the risk natural thinking in a simple meaning, this leads to something called a risk natural valuation, right? It does not means the risk is disappear. It means the for the calculation part, right? We imagine a world where everything expect only on the safe return, right? This imaginary words makes a pricing easy, and surprisingly, the price we get there, right? So also works in real words, the famous formula it is, right? So all this logic leads the Black and Scholes formula. And don't worry about the maths. We calculate on our Excel sheet in a very simple way. So in simple words, the formula says that the option price depends on the what you might gain, what you might pay, and the chances of it happening, right? That's it. So the reward minus cost adjusted for the probability, right? So how traders use it are today? So today's traders are does not usually calculate the option price from the scratches. The market has already gives us the option price. So we will work on a backward. We plug in everything we know and find the missing piece, right? So that missing piece is called implied volatility, right? Then the fear gauge is the VIX. So VIX is just implied volatility of the S&P 500. If we have a high VIX, it indicates the market is very nervous, and low VIX indicates the market is a very relaxed position, right? So when news says a market fear is a raising, they are literally talking about the volatility, right? So that's the Black and Scholes speaking. Then the final thoughts of in a Black and Scholes does not removes the risk, right? It gives us a way to measure and price it. Knowing the price of the risk does not means you are the safe from it, and that's the real lesson, right? So now we can understand the theory part, right? Let's solve the Black and Scholes model step by step in a Excel sheet using our real numbers, right? So let's start with the calculation part, right? So this is the formula for the Black-Scholes method. And suppose we calculate the call and put price for the Wipro shares, right? So that is the start date and end date. And we suppose the spot price, this and strike price would be the this. So the T for the tenure and R for the risk-free rate, right? And or to the RF value, right? So suppose that would be 10%, right? And spot price, it's a current price of the stock, right? Current price. And strike price, it is the right, but not, but not obligation, right? And T for the tie and R for the risk-free rate, RF, right? And for the trading days, that would be the 252 trading days in a year, right? So 12 months divided by 252 days, right? Use 252 trading days, right? And again, the value of T, and we also calculate the square root, right? So the next part is variance standard deviation or the calculation, right? And standard deviation is measure the annual volatility, right? annual volatility, and variance is how much spread are the wide. The wide, right? And e to the power rt, it indicates the discounted factor, and k into e to the power minus rt indicates the uh, present value of strike price, right? And it would be indicates the volatility over the time, right? So for the calculation part, first we calculate the variance, right? So variance for the calculation, it's use a formula LEN. Sorry, it is the LN, spot price divided by the strike price, right? And standard deviation is the square root of the variance. So it is the 26th percentile, right? So for the calculation, e to the power minus rt, it is the exponential minus r into t, right? And next one is k e to the power minus rt. So exponential minus right? And for this calculation, it would be the annual volatility into, yeah. And the next, it is our D1 calculation for the D1, right? And D1R indicates, sorry, D1 indicates the, this indicate how far the strike can go above the strike price at this time, considering considering volatility and time, right? And for the similar D2, this indicates D2 indicates whether the stock will be the above of the strike price at the expiry or not, right? The indicates whether expiry, right? And even indicates if the stock price increase by $1 and how much the option price would be the increase, right? So that is the standard deviation of D1, right? And similar to the and D2. So D1 indicates the if the stock price and D2 is a call option ITM, right? So stock price it's greater than to the strike price at the expiry, or for the put option, it is the stock price is less than strike price for at the expiry, right? So for the call option, so for the D1 calculation, we just putting the values in the formula and getting the value, right? So for the D1 calculation, right, equal to we just putting the all the values in the formula, right? Right? And it is the relation between the D1 and D2 is D1 minus sigma root T, right? So we can easily find the D2, right? That is the and D1 it's normal distribution, right? So and for the calculation on our D1 and D2 minus D1 and D2, it's would be a simply 1 minus and D1 and 1 minus and D2, right? And for the call option price, we just putting the values on this formula, right? That is the 175. And for the put, so we can get the values of call price and put price, right? And I have shown a formula which I have used for your references, right? So we can get a call option price and put option price for the Wipro stock, right, by using a formula in a Black-Scholes model. So, and you can easily make this type of a template. Thanks for watching and like, share, subscribe for the Quant task, right?